Hello everyone, welcome to the Mechanism channel. Today's topic is Global Tolerance Standards. Global Tolerance Standards provide consistent guidelines for specifying tolerances in engineering, drawings, manufacturing, and quality control. These standards are essential to ensure compatibility, interchangeability, and consistency of parts produced in different regions and industries. Here's an overview of the most widely recognized tolerance standards used globally. In ISO 27768, general tolerances for linear and angular dimensions. Scope applies to machine parts and covers. General tolerances for dimensions without individually specified tolerances. Tiers ISO 2768M medium for general parts with standard manufacturing precision. ISO 2768F fine for precision components requiring tighter tolerances. ISO 2768C coarse for parts with larger dimensions or where high precision isn't critical. ISO 2768V very coarse used for rough manufacturing processes. Tolerances linear dimensions in millimeters range from plus 0.1 to plus 1.5 depending on the dimension range. Angular tolerances range from plus 1 degree to plus 3 degrees based on the size of the angle. 2. GD&T, geometric dimensioning and tolerancing. ISO 1101 and ASME 14.5. ISO 1101 is the international standard for defining geometric tolerances, while ASME Y14.5 is the American standard for GD&T widely used in North America. Scope specifies the allowable variations in form, orientation, location, and run-out of features. Form tolerances include straightness, flatness, circularity, and cylindricity. Orientation tolerances cover angularity, perpendicularity, and parallelism. Location tolerances include position, symmetry, and concentricity. Runout tolerances cover circular and total runout. DIN 7168 and 7169 are the German tolerancing standards. DIN 7168 is for general dimensional tolerances, now largely replaced by ISO 2768. DIN 7169 is similar to DIN 7168, but applies specifically to fine tolerances in more precise machining operations. These standards are used widely in the German-speaking regions and industry, with a strong focus on mechanical engineering. There are different tiers: DIN 7168 medium, which is comparable to ISO 2768M, DIN 7168 fine, comparable to ISO 2768F, and DIN 7168 coarse, comparable to ISO 2768C. ANSI, ASME, B4.1 and B4.2 define limits and fits. ANSI, ASME, B4.1, also known as the Unified Inch System, defines standard tolerances and limits for mating parts in the inch system and is widely used in North America. ANSI, ASME, B4.2 is similar to B4.1 but specifies tolerances and limits in the metric system. There are different types of fits: a clearance fit, where parts easily slide or rotate against each other, like in a shaft and bearing assembly; an interference fit, where parts must be pressed or forced together due to overlap in dimensions, such as in press fit bushings; and a transition fit, where parts may either slide or be press fit depending on their individual tolerances. ISO 286-1 is the ISO system of limits and fits. This standard defines a system for tolerances and fits for mating parts, like shafts and holes. There are different fit types: a clearance fit, which allows free movement between parts; a transition fit, which provides intermediate tolerances; allowing for slight interference or clearance, and an interference fit, which ensures tight press-fit assemblies. These are primarily used for shaft and hole systems in mechanical and manufacturing industries. JIS B0401 and B046 are the Japanese standards for tolerances and fits. JIS B0401 defines tolerance grades ranging from IT01 to IT18, which is quite similar to the ISO 286. On the other hand, JIS B0416 specifies limits and fits for holes and shafts, also similar to ISO standards, but adapted to Japanese manufacturing practices. The fit types include clearance, transition, and interference fits, following a system that is quite similar to both ISO and ASME standards. These standards are primarily used in the Japanese manufacturing and automotive sectors, and are closely aligned with ISO systems. The British standard for limits and fits is outlined in BS 1916-1 and 2. This standard serves as the British equivalent to the ISO 286 system, specifying tolerances for shafts and holes. BS 1916-1 deals with tolerances for precision fits, ranging from IT01 to IT16, and the corresponding clearance, transition, and interference fits. Meanwhile, BS 1916-2 provides recommended practices for the engineering design and use of limits and fits in British industries. Moving on to casting tolerances. ISO 8062 specifies dimensional tolerances for cast parts, whether metal or plastic. This standard ensures uniformity in global casting operations. It's commonly applied to engine blocks, pump housings, and other large-scale cast components. Next, we have ISO 10110, which defines tolerances for optical components, including lenses, mirrors, and prisms. The standard categorizes tolerances into surface form, which addresses deviations in the surface curvature and surface imperfections, such as scratches, pits, or other flaws. These tolerances are crucial for high-precision optical systems like cameras, telescopes, and medical devices. Thanks for watching. Please like, share, and subscribe. Happy learning.